It's my first time at CppCon. I've thought about going for a lot of years and now kind of regretting that I didn't go sooner.
So hi everyone, I'm Raf. I am a tech lead at Maven, but in my spare time I work on DepC, and I want to talk to you and I want to tell you about the proof searching algorithm that I have implemented in DepC. First of all, what it is proof searching. In type theory, there are two important questions that are asked. One is type checking, the other one is proof searching. Type checking is what we are all familiar with and what compiler usually do. If I have X and an expression X, does it have type T? Proof searching is the opposite thing. If I have a type T, can the compiler find a value of that type? If this is searching a value, why is it not called value search? Why is it called a proof search? That has to do with a thing called carryover correspondence. You can go and Google it up. It's very interesting, but moving on. This is an example DepC program. It does nothing, it just returns 0. It has the usual argc, argv pattern, but now you can see that argv depends on argc at runtime, which is really interesting. Now let's make it do something more interesting than this. We can declare put s from libc. We can use it to print the first argument of the program, which is obviously the second argument of argv, but the compiler will complain that we haven't proved that 1 is within bounds. So how do we prove that 1 is within bounds? We can simply check that 1 is less than argc, and then within the if branch, we have now proved that 1 is within bound. The compiler, through using the proof search algorithm, will find this proof. Otherwise, if you're lazy or if it is too hard to prove things, you can just cheat and ask the compiler to believe you. If you know anything about type theory, that has the same type of the function absurd, so it is absurd to trust the programmer. The interesting fact there is if your claim is not true, what you get is the usual undefined behavior that you get in C and C++, but now you can literally grep for it using fgrep, and I think that's awesome. Now, in either case, what you end up with at some point within the compiler, you end up hitting this function here, which is type assigning. So you have the expression coming from the parser. I detect that that is a array access operator. So then, because of that, it's gonna look for a proof that the index is within bound. That proof is this thing here. It will create a task which will spawn multiple subtasks because it will need to apply multiple different tactics in order to find a proof. Now, if you know anything about type theory, this thing is undecidable, so you're not guaranteed to find a solution, but sometimes you do expect it to find a solution. When you do expect it to find a solution, but it can't, I can turn on Perfetto to trace exactly all the things that it tried and explain why it didn't find a proof that I hope it would find. And that's it. Thank you very much.